copy of the notes now? Wonderful. Now, today we'll be moving on into chapter 8, moving on from chapter 7. So 8.1, or basically chapter 8, we'll be dealing with quadratics, quadratic functions, graphing them, things like that. Today we're just going to be learning things about quadratic functions. So, does anyone remember what a function is? No? Alright, well, a function is basically what you were doing in your assignment. You were given an equation. Any number you put in should give you exactly one answer when you're all done doing your math stuff. So for all your problems in the homework, put in one number, you got one answer, right? So that would be considered a function. Now, what makes something quadratic? Well, so quadratic means degree 2. So when we're dealing with quadratic functions, it's going to be a function that is going to be degree 2. And a quadratic function is any function that can be written in the standard form ax squared plus bx plus c. Alright, so does that look familiar? Ax squared plus bx plus c? Because we were just factoring trinomials. Yeah. So there's also one very important part. A cannot equal 0. So why do you think A can't be 0? Why couldn't A be 0? Well, if A would be 0, it'd be 0 times x squared, right? Well, what's 0 times anything? 0. So we wouldn't have an x squared in our equation then, right? It would just be 0?
Yeah.
So in order to be a quadratic, you have to have an x squared. So that's why A can't be 0. Now, next one, the simplest form. It's also called the parent function. The basic, simplest form that any function can be is called the parent function. That one is y equals x squared. So, just like any quadratic function or equation, we can always have an a, b, and c value. So for y equals x squared, what do you think our a value is? Nick? A is 1. How about b and c? Russell? 0. That's exactly right. Because b goes with our x part. There's no just x part in there, so b would be 0. There's no constant, so c would be 0 also. Alright, now. The graph of a quadratic is a smooth curve that looks like a U. That's what you guys are doing, and that has a special name called a parabola.
We just learned about this in science.
Yeah, so everyone say parabola because it's a fun word.
Parabola. That's the shape.
Yeah.
Think tape.
So parabolas are the U-shaped graphs. You were doing at least 5 of them on your assignment that you did today. So it either opens up or down. So when it opens up, if you look on your assignment, what does it look like? It looks like a U. So when it opens up, it looks like that. If it opens down, what does it look like?
A pencil.
An N or an upside down U, right? So based on whether it opens up or down, that is controlled by the A value. So the value that's paired with our x squared, that will determine if our graph is going to open up or it's going to open down. So that first one, when A is greater than 0, what's another way of saying greater than 0?
Positive.
Positive. So when A is positive, the function's gonna open which way?
Up.
Up. So if you look on your assignment that you did today, for any one of those where A is positive, does it open up?
Yes.
So like number 3, A is positive, so that should open up. And when A is less than 0 and when A is negative, which way do you think it's going to open? Down. And then number 5 shows an example of that one. So when A is positive, it opens up. When it's negative, it opens down. All right, next one. They change direction at a certain point. So I'll just over here, there's one that opens up. So what can we say about that one's A value just right away? No. A would be positive for that one. So the point where they change direction has a special name called the vertex. So for example, this one, when we're going left to right this way, we're decreasing, decreasing, going down. When we get right here at the very bottom, that's our vertex. So at that point, when we keep moving this way, all of a sudden we're going up, increasing, going on forever. So the vertex is where you go from either decreasing to increasing or increasing to decreasing. So now, next one, when A is greater than 0 or when A is positive, just like that one, the y value of our vertex is called the minimum. So why would it be called the minimum? The y value, why would that be called the minimum? It's because it's the bottom, it's the lowest point on this graph. It's the minimum value that y can be. So that's why it's called the minimum. Then, this one, when A is less than 0, that's what that one would look like. We have our vertex right up there. What do you think the y value of the vertex is called in this one? Maximum, right? So when it opens down, you have a maximum, because only that one is the highest one. When it opens up, you got a minimum. Alright, next one. It has an imaginary line that divides it into 2 symmetric halves. So what does symmetric mean?
When you cut it in half, it can fold into be one.
It means same. So on one side it's equal to the other side. So, just in these 2 examples, if I draw an imaginary line right through it, everything on one side should be the exact same as what's on the other side, just different values, but if we flip it over, it should be right on top of each other. Same with this one. We go right down the middle. Doesn't look like it because I'm an awful artist, but bear with me. So, these 2 imaginary lines, that has a special name called the axis of symmetry. Alright, so anyone have any questions so far about properties of quadratic functions or equations? Alright, so I have questions for you because I've forgotten already. When can the parabola open up, or when does the parabola open up?
When it's positive.
When what's positive? When A is positive. How about when it opens down? Right. What's that point where it changes direction called? Vertex, right. Alright, just making sure you guys are paying attention. Alright, moving right along to the backside. Sometimes we'll be asked to tell if a function represents a quadratic function. So we will just be given any equation. It might not be in standard form or even written in ax squared plus bx plus c form. So what we have to do is get it in that form. So first thing we always do, we solve for y, or get y by itself. Y is all alone on one side, everything else is on the other one. After we get y by itself, we try to get the other side in standard form. So what is standard form again? For a quadratic, standard form is ax squared plus bx plus c. But just in general, standard form is greatest degree at the front to the least degree. So we just got to get it greatest degree to least degree. And once we do that, we check to see if it is in quadratic standard form. So that's when we check for ax squared plus bx plus c form. Now we just got a practice problem. If we follow the steps in our notes, it says get y by itself. How do we do it? It's such a challenge. Minus 7x to both sides. We're left with y
Equals
equals
5 minus 7x.
5 minus 7x.
Or negative 7x plus
Question, is that in standard form the way it is right now?
No.
So we'd have to rename it, that's when we write it in standard form, so y equals, I heard someone say it before,
Oh, that's the
Negative
one.
Negative 7x plus
so it's greatest degree to least degree. Alright, so we have our equation, y equals negative 7x plus 5. Now we have to see if this satisfies being a quadratic.
No, it doesn't.
So who says yes? Yes, it does.
What was the question?
Is this a quadratic?
Yes.
Yes.
No.
Come on, the iffy side.
Who says no? Alright, well, the way we check is if it satisfies looking like this, ax squared plus bx plus c. Should be able to have an a, b, and c value.
We don't have a C and plus the X isn't
We don't have an
squared.
ax squared.
So, question, is there an x squared in this one?
No.
So what does that mean our a value is?
Zero.
Zero. And what does that mean?
Can't have it.
Quadratics can't have a, b, and 0. So this one,
It's not.
this is not a quadratic. And the reason that is because a is 0.
Do you have to explain why?
Yep. So the way you would explain it is just a equals 0. Alright. You guys share number 2 by yourselves.
I can do it, you.
Yeah, seriously.
Okay, Mark. Show us up.
We have to graph today.
What do you do when you put it in standard form?
AX squared.
Oh, that's so right, because it's gonna be ax squared plus bx plus c, so it's gonna be negative. It's gonna be 5, y
You never
equals
answered
5x squared plus 2x minus.
Are we
Am I right?
Am I right?
No.
Justin,
It was funny.
no.
What'd you
Because
say?
Miss LeGrand leaves the room doesn't mean you get to go wild.
Are we graphing today?
No, not today. So when we get y by itself, so to do that, we add 5x squared to both sides. And if you're real good, you can just try to write it in standard form right away.
Yes, it is.
And some of you did, some of you might not have, either way is fine. So, yes, it is a 6. I have awful handwriting, I'm sorry. Alright, so 5x squared plus 2x minus 6. For any quadratic, we should be able to have an a, b, and c. So what's our A, B, and C for this one?
A is
Two and
5,
negative
B
six.
is 2, and C is -6.
And C is -6. So based on that, we can say that this one is a quadratic.
So that's all we have to show for it.
Yep. For ones where you have to identify if an equation is a quadratic, this is the word you have to show for it.
I think that's what this is.
Mhm. This is quadratic. Alright, now, the next one, sometimes you won't even be given an equation to write in standard form. Sometimes you'll just be given table of values or ordered pairs, and you'll have to use those to see if they represent a quadratic function. The way we do this is that we look for a common second difference. So common second difference. Look for a common second difference in the y values when there is a constant change in x. So first thing we have to do is see if there is a constant change in the x values that we're given. And if there is, then we can move on to finding a second difference. So this first one, number 3. What is happening in between the x values? So from -2 to -1, what's happening?
We're adding 1,
Adding 1, right? How about this one?
adding 1,
Adding 1. How about this one and this one?
adding 1.
Adding 1. So is there a constant change in our x values?
Yes, there is.
And what is it?
1.
Plus 1, right? All right, so when this is talking about second differences or first differences in the y values, all that means is what is happening in between each y value. So from like 8 to 2, what are we doing?
Subtracting
Subtracting
6.
Subtracting 6, right? And how about 2 to 0?
Subtracting 0.
Subtracting 2.
Or 2.
And 0 to 2?
Adding
Adding
2.
Adding 2,
six.
adding 6. So this is the first difference in our y values that we just found.
But they're not all the same.
But they're not all the same, so
It's not quadratic.
You have to do it again.
What?
we don't know if this is quadratic. We're looking for the second difference for quadratic.
So you have to-
We have to go one more step. But, question, if these were all the same number, we'd have a common first difference, right? So what kind of function do you think that would represent?
Wait, wouldn't that be a non-quadratic? It should only be 2.
Well, it would not be quadratic, right?
Yeah.
You already learned this back in chapter 4, come on.
Honestly, I don't know.
That was a long time ago.
Linear.
There it is, it would be linear. So, what degree is a linear function to? You know, one. So it would be like y equals mx plus b, that's just to the first degree. So when we find a first difference, if they were all the same number, we could say we have a common first difference, this is a linear function. But since this one, they aren't all the same, we can say that this is not a linear function. We're not trying to find linear functions anyway, so we can just keep going. Now, when we're trying to find the second difference, these values that we found right here, -6, -2, 2, and 6, we then use those to find the second difference. So all we do is go from -6 to -2, what are we doing?
Oh, you're adding.
Plus 4, -2 to 2, plus 4, adding 4. This is our second difference that we just did. So our second difference, they're all plus 4, so that means it's a common second difference or a constant second difference. So since they're all the same, and there's a second difference, What can we say about this?
It's
What's the
linear.
difference in y?
No.
It's linear.
Second difference,
In y.
what are we trying to find?
It is a quadratic.
It is a quadratic. So this is a quadratic. So again, what degree is a quadratic to?
One.
Two.
2. Quadratics are degree 2.
Linear.
So, first difference, those are linear because they're degree 1. Second difference, 2 quadratics are degree 2. So, here's just an if statement. If those weren't all the same numbers, we had to keep going, and our third differences were all the same, what kind of function would that one be?
A triangle.
No. Degree 3, right? So what is a degree 3?
Cubed.
Cubic,
Cubic.
right. We're not dealing with cubics today, we're just doing quadratics.
So we don't have to go a third degree.
You do not, the furthest you should go is the second difference. Anyone have any questions about anything in the notes?
Sorry.
All right.